Hi. Today the main topic is what is an orders decoding, and yesterday I just talked about what is it, orders decoding and the background of it, and now I'm just gonna try to deep dive more about orders decoding. Like I just said, orders decoding is to handle the mismatch between the input address line and the output address lines. Example, you have the microprocessor that has 10 address lines. And you have three address lines. If it is 10, three address lines for the selecting the one chip. So that will be here some kind of decoder, and this kind of how many chip it has. And let's assume that we need 8 memory chips. So there's gonna be 1, 2, 3, 4, 5, 6, 7, 8. Sorry about drawing, but let's just skip this. And the reason why we need some kind of decoding thing is because the mismatch between address line and the quantity of the chips. The even memory chips require some kind of address lines. And edges means that it needs to have the one at least one address lines, right? Because there should be 8, and there should be address line for each chip. And but the thing is that we only have 3 address lines to go to this selecting the 8 chips. And to handle this kind of mismatch, we need some kind of decoder, 3 to 8 decoder. And I know there's like other address lines to select the internal cells of the memory chips in here, but I'm just gonna skip this right now. I'm just gonna elaborate this kind of 3 to 8 decoder set. In decoder, there's like 2 strategy: full address decoding and partial address decoding. But right now I'm just gonna talk about the full address decoding. Full address decoding, it just means that you have 3 address lines, so that will be some kind of 0, 0, 0. Why we need some kind of 0, 0, 0 value? Because the address lines store the value, the binary value, which is 0 or 1. So the address line could have 0 on 1 value. The question is, you given 1, 0, 0 input of it. If you say this is the 8, 9, 8, 7, 8, 8, 8, 8, 8, A7. This A stands for the address lines, right? And you given 1, 0, 0, the value of it. But what's the chip we wanna get based on this input? It's kind of nonsense, right? We are trying to guess this value of it based on this input, but we don't know the value of it. To handle this kind of mismatch, to handle this kind of question, we use 3 to 8 decoder. And furthermore, inside this kind of decoder, we are using the logic gates. So what's the logic gates? So logic gate is basically is example. Example is just AND gate, NOR gate, OR gate, XOR gate, and those kind of stuff. Basically, we're just using this logic gate to make this decoder. Let me try to elaborate more. we knew that we only gonna use these three other lines. Let's say A9, A8, A7. In the sorry, okay, this part. But we gonna select some kind of chip, right? The chip's gonna be this part. We had 8 chips, so the A, YL, Y1, Y2, Y3, Y4, Y5, Y6, Y7. So that's gonna be 8 chips, right? And devices, the memory one. Let's say we want to draw a truth table. So what is truth table? So truth table is just basically the table that represent the current binary value. What I believe is, you have a. It's very simple. You just want to do 0, 0, 0. That has to be some kind of distinct value. 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. And that's simple, right? And the chip, I didn't talk about the really key thing. We are trying to, our purpose of orders decoding or those kind of stuff, we are trying to select the one chip. We have some kind of random value like 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and 1, 0, 0, those kind of stuff. But our purpose is to use this value to get the one distinct chip. And that's really distinct. If it is 1, 1, and 0, 0, 0, there's duplicate, right? There's duplicate, and there's gonna be corruption of it. We want to select just one value. So we can just draw this table like this. 1, 0, 0, 0, 0, 0, and 0, 1, 0, 0, 0, 0. So 1, 1, 1, 1 like this. And 1, 1. So that's kind of distinct, right? 0, 0, and 0, 0, 0, 0, 0, 0, those kind of stuff. And this part is really distinct. So that means that we just want to get this value. So which also means that we know the inputs of it, we know the possibilities of the input values, and we know possibility of output value. There has to be one. There has to be